Hello friends, welcome to my channel. This is Fluid Mechanics Isro question paper part 2. Question is, the horizontal component of force on a curved surface is equal to a product of pressure at its centroid and area, b weight of liquid retained by the curved area, c force on a vertical projection of the curved surface, d weight of liquid vertically above the curved surface. So, horizontal force Fx is rho g a h bar. H bar is distance of Cg. A is projected vertical area. Vertical area. And vertical force Fy is this D answer. Fy is D. Weight of liquid vertically above the curved surface. But in this question they asked horizontal component of force Fx. So it's force on the vertical projection of the curved surface. C is our answer. Next, the maximum depth from which a centrifugal pump can draw water is A dependent on the speed n of the pump, B dependent on the power of the pump, C around 10 meter, D depend on n square. C is our answer. It's around 10 meter. Two pipe lines at a different pressures PA and PB, each carrying the same liquid of specific gravity of S1, are connected to a U-tube with a liquid of specific gravity of S2, resulting in the level of differences H1, H2 and H3 as shown in the figure. The difference in pressure head between points A and B in terms of head of water is how much? So here we will apply jumping fluid technique. So from A point we will start. From here we will start. So PA minus rho G1, then H1, then rho GH1 is from here to here. This, then from here this side cancelled. Here this one also cancelled. Only H2. So H2 rho G 2 into H2. Then from here to here rho G 1 H3 minus PB equal to 0. So PA minus PB we have to calculate the difference in pressure head between points A and B. So it's rho G1 H1 plus rho G2 H2 plus rho G1 H3. Here specific gravity term we have to use. So, and in terms of head S1 H1 S2 H2 plus S1 H3. So from option S1 H1 plus S2 H2 plus S1 H3. D is our answer. List 1 gives 4 dimensionless numbers and list 2 gives the types of forces which are one of the constituents describing the numbers. Match list 1 with list 2 and select the correct answer using the codes given below the list. List 1 Euler's number, B Froude number, C Reynolds number, D Weber number. List 2 1 pressure force, 2 gravity force, 3 elastic force, 4 surface tension, 5 viscous force. First we will discuss Euler number. It's inertia force by pressure force root over V by P by rho whole root over. Then Froude number. Froude number is inertia force by gravity force whole root over V by GL whole root over. Then Reynolds number. Reynolds number is inertia force by viscous force rho VL by mu or VL by kinematic viscosity. Then Weber number. Inertia force by surface tension force root over V by sigma by rho L whole root over. Then Mach number. Mach number also important. Inertia force by elastic force whole root over V by C. Actual velocity by sonic velocity. So Euler number is pressure force A, B, C, D. Euler number, pressure force, Froude number, gravity force, Reynolds number is viscous force 5, Weber number, surface tension force 1254, 1254. C is our answer. A single stage impulse turbine with a diameter of 120 cm runs at 3000 rpm. The blade speed ratio is 0.42. Then the inlet velocity of steam will be how much? Data given are D equal to 120 cm equal to 1.2 meter. Then RPM n equal to 3000 rpm. Blade speed ratio, it's rho u by v1, small u by capital V1, it's 0.42. Inlet velocity of steam we have to calculate. Here u is blade speed, small u, it's blade speed, and V1 is fluid velocity at blade inlet. At blade inlet. This one we have to calculate, inlet velocity of steam V1. So blade speed ratio rho u formula is pi dn by 60. So it's pi into d is 1.2, n is 3000 divided by 60. So this is 50. Then 1.2 into 50, it's 60 into 3.14. So if you multiply this one, 188.4. So u is yes, then v1 we have to calculate. v1 equal to small u by rho. Small u is 188.4 divided by 0.42. So v1 equal to 188.4 by, let it be 0.4. So it will come around 4 into 4 16, 28, then 7, then 1 meter per second. From option not possible, B also not possible, D also not possible. C is our answer. 450 meter per second. One more technique I will tell you here. Here blade speed ratio rho is less than 1 and v1 is always greater than u. So from here we got u is 188.4. So v1 should be greater than 188.4. So A is also not possible, B also not possible. By this we can omit A and B. Then we have to calculate for C and D. From here C is our answer. For laminar flow over a flat plate, the thickness of the boundary layer at a distance from the leading edge is found to be 5 mm. The thickness of the boundary layer at a downstream section, which is at twice the distance of the previous section from the leading edge, will be how much? Boundary layer at a distance from the leading edge found to be, so delta by x equal to 5 by rex whole root. This formula we have to use for laminar flow. This one already mentioned, laminar flow. So delta x1 is 5 mm at distance x1 from the leading edge. Delta x2 we have to calculate at distance x2 equal to double of that previous one. So x2 equal to 2x1. Here we have to use delta x by x equal to 5 by b into x by kinematic viscosity root over. So delta x equal to 5 into x b into x by kinematic viscosity root over. So delta x equal to 5 into root x by b by kinematic viscosity root over. So from here delta x is proportional to root x. This relation we have to use in this question. Boundary layer thickness delta x is proportional to distance of the leading edge. This is for laminar case. One more thing is important. For turbulent flow, it's x to the power 4 by 5. Turbulent flow. But in this case, already mentioned for laminar flow. So by root delta x1 by x1 root x2. So we have to calculate delta x2. Delta x1 into x2 by x1 root over. x2 is 2 times of x1 into 2x1 by x1 root over. Delta x1 already given 5 into root 2. So second condition, boundary layer thickness delta x2 is 5 root 2. unit is mm. So from option 5 root 2 mm, B is our answer. The distance from the leading edge in second case. If u infinity equal to free stream velocity, small u equal to velocity at y, and delta boundary layer thickness, then in boundary layer flow the momentum thickness theta is given by how much? Three things are important: displacement thickness, delta d is theta here, energy thickness delta e, delta d displacement thickness is 0 to delta integration 1 minus small u by u infinity dy, and for momentum thickness 0 to delta small u by u infinity whole into 1 minus u by u infinity dy. For energy thickness 0 to delta u by u infinity 1 minus small u by u infinity, this is square, into dy. In this question momentum thickness asked, this one, u by u infinity 1 minus, so A is our answer. And this one for energy thickness, u by u infinity square, this one for displacement thickness. Thank you friends. Thank you for watching my video. If you like my video, then subscribe it.